Another example, greatest integer function of 2.7. So you have to write down the integers less than or equal to 2.7. So 2.7 is not an integer. So we have to write down the integers less than 2.7. So what are the integers less than 2.7? It is 2, 1, 0, -1, -2, etc. Out of these integers, which is the greatest integer? That is 2. So greatest integer function of 2.7 is 2. Now listen, greatest integer function of 2.1, 2.2, 2.3, 2 point whatever it is. So its greatest integer function value is 2. Now what about negative 5.4? It is a negative number. Negative 5.4 actually it is not an integer. So we have to write down the integer less than negative 5.4. So if we draw the number line, we can see it is 0. Then left of 0 is negative numbers, -1, -2, -3 and so on. So less than negative 5.4 means what are the numbers? Look at the real line. So it is -6. So negative 5.4 means listen, assume this is the number negative 5.4. So the numbers or integers less than negative 5.4 means it is -6, -7, -8 and so on. Out of these integers, which is the greatest integer? It is -6. Okay. From left to right, numbers are increasing. So -6, -7, -8 is decreasing form. So what is the greatest integer? -6. Now listen, -3.2. Look at here, -3.2 means assume this is the point -3.2. So we have to write down the integers less than to this -3.2. So the integers are -4, -5, -6, -7, etc. Out of these integers, which is the greatest integer? It is -4. Okay. Now what about greatest integer function of 7? That is 7 itself. What is 7.1? It is 7 itself. What is -7.1? It is -8. See the difference. If it is negative number, you have to add 1. Okay, keep in mind, you have to add 1. If it is a integer, then the greatest integer function is the given number itself, given integer itself. It is positive 7 point, 7 point something. Then integer part you have to concentrate. So the answer is that integer. If it is negative number, you have to add 1 with the integer number, integer part. So you will get the answer. Okay. Anyway, if you take any number in between 0 and 1. Okay, in between 0 and 1, that is 0 less than x less than 1. Suppose x equal to 0.1, 0.2, 0.3, 0.005, whatever it is, the greatest integer function of x is equal to 0. Okay, if it is equal to 0, then the greatest integer function of x equal to 0. If you take the value of x is 1 point something, suppose 1.1, 1.2, 1.3, 1.999. Okay, and also if x equal to 1, then the greatest integer function of x is equal to 1. If you take x equal to 2.1, 2.3, 2.4 and so on, so its greatest integer function becomes equal to 2. Is clear? If you take negative values, suppose -0.1, -0.2 and so on. Okay, you just listen. Okay, negative 1 less than or equal to x less than 0 means you consider the x value in between 0 and negative 1. 0 and negative 1 means negative 0 point something. So in this case the greatest integer function becomes, what is the answer? See the greatest number, it is negative 1. That means negative 0.5. So here you have to identify it is a negative number. So integer part is 0. You have to add 1. 0 plus 1, 1. So greatest integer function becomes negative 1. Okay. So in this manner we can define greatest integer function. Now see what is its graph. Okay. Let's see the interval 0 less than or equal to x less than 1. So this is the interval which means the value of x lies between 0 and 1, including 0, excluding 1, like 0.1, 0.2, 0.3, 0.005, etc. So for these integers, for these numbers, greatest integer value becomes 0. So look at here, the interval 0 and 1 is this. Including 0 means darken the point 0. Excluding 1 means just encircle. Okay, just encircle 1. So this is the values of x. So in this x values, y becomes, y means our greatest integer function value, y becomes 0. So this is the graph. Okay. Now in this interval 1 less than or equal to x less than 2. 1 less than or equal to x less than 2 means the value of x lies between 1 and 2, including 1, excluding 2. So listen, including 1, excluding 2. So in this interval, the greatest integer function value or y value becomes 1. Or simply we can say, for these x values, y value become 1. For example, if we take x equal to 1, then y is 1. If we take x equal to 1.1, y value is 1. 1.2, y value is 1. 1.23, y value is 1. For all 1 point something value of x, y value is constant, that is equal to 1. So if you consider this interval, the y value is constant. So this is the graph. And here this darken indicates including 1 and excluding 2. Now next interval 2 less than or equal to x less than 3. 2 less than or equal to x less than 3 means the value of x lies between 2 and 3, including 2, excluding 3. That means we can take the value 2 or 2.1, 2.2, 2.3, 2.9, etc. When value of x is 2, then the greatest integer function of the given value is 2 itself. So 2, 2. If you take x equal to 2.1, then the greatest integer function is 2. If you take x equal to 2.2, then the greatest integer function of 2.2 is 2. Whatever it is, the y value is 2. So this is the interval. So in this interval, for any values of x, y value becomes constant. What is the y value? 2. And here 2 is included and 3 is excluded. Okay. So darken 2 and encircle 3. So in the similar manner, we can consider the next interval 3, 4. So in this interval 3, 4, for any values of x, greatest integer function becomes 3. So this is the line, and 3 is including and 4 is excluded. Okay. So it is just like step. So greatest integer function is also known as step function. Okay. Step function. Similarly, we can consider the negative numbers also. You can see like this. Okay. The same manner we can proceed. So this is about greatest integer function. Polynomial function. So, a polynomial function, there is no special definition. We know polynomial. What is a polynomial? Polynomial is an expression in variables and with some non-negative integer. Okay. So, for example, 2x plus 3, it is a polynomial. X square plus x plus 1, it is a polynomial. Then x, it is a polynomial. 2 is a polynomial. 2 is a constant polynomial. Okay. So, a polynomial means there is a variable with real coefficients. Okay, with the real coefficients. So, the graph of the polynomial function depends on the polynomial function. For example, we have a polynomial function f of x equal to just 2x. So, find out the points to draw the graph. When x equal to 1, f of x becomes 1 into 2, 2. When x equal to 2, f of x is 2 into 2, 4. When x equal to 3, f of x becomes 6. So, using these points, we can draw the graph. Okay. So, we can draw the graph of polynomial function depends on the polynomial given. There is no special definition for polynomial function. So, okay. So, in this case, domain is what? Domain of a polynomial function is set of for real numbers, because we can select any real number for x values as x values. Okay. So, nothing special about polynomial function. So, give more importance to identity function, constant function, then modulus function, signum function, and also greatest integer function. Okay. So, that's all about functions and their graphs. Next, we will see how to find domain and range of a function using problems.